Hi everyone, I hope you're okay, and I hope that guys the videos will keep uploading and helping you out. This is video number 3 guys, whereby I'm tackling the past examination question papers, but I'm only focusing on the Newton's laws. uh, yes, this is a grade 12 question paper. However, grade 11s can also watch this video and answer the question, because Newton's laws are basically taught in grade 11, so got nothing to lose. Before I even start, guys, please do share the video to your peers. A thing or two that will be mentioned here might help them, whether elevate their knowledge in Newton's laws, or help them towards an upcoming test or an upcoming exam. Uh, and most importantly, guys, please don't forget to subscribe to help us grow the channel. Obviously, like the video if you're getting helped, and comment if there are questions you have. Okay, so now let's start. In the diagram below, a small object of mass 2 kg is sliding at a constant velocity of 1.5 meters per second down a rough incline at 7 down a rough plane inclined at 7 degrees to the horizontal surface. Okay. The first thing that guys we need to show here, there's position A, position B, let's say there's position C there, or rather let's put C there. We are told that the object is sliding at constant velocity. When there's constant velocity, guys, it simply means there's no change in kinetic energy. Also, there's no change in thingy. There's no change in the constant velocity, right? There's no change in kinetic energy, no change in velocity, and hence there's no acceleration. Are you together? Since the acceleration is 0, it simply means that F net is also 0. Are you together? And obviously for matriculants, work net is also 0, since the change in kinetic energy is 0. Okay, at the bottom of the plane, the object continues sliding into the rough horizontal surface and eventually comes to a stop. Okay. The coefficient of kinetic friction between the object and the surface is the same for both the inclined surface and the horizontal surface. Okay, 2.1, they want us to write down the magnitude of the net force acting on the object. The net force acting on the object as it slides down is 0 newtons. Why am I saying that? Because the object is moving at constant velocity. Since the velocity is constant, that means acceleration is 0. Why is acceleration 0? Remember that by definition, acceleration is the rate at which velocity changes. If there's no change in velocity, that means there is no acceleration. And when there is no acceleration, the resultant force, or rather the F net, is equal to 0. So the magnitude of F net is just 0 newtons. Okay. 2.2, they want us to draw a free body diagram for the object while it is in draw a free body diagram for the object while it is on the inclined plane. Okay, on the inclined plane, the free body diagram, you can draw like this now. There's obviously weight, gravitational force, and then we do have frictional force that opposes the motion of the of the object, and then we have our normal force, which is perpendicular to the surface. You can draw it like this, but please guys, do not leave your forces like this. Nah? Please do write in full: normal force, kinetic friction, and the weight. Write in full. Nah? The free body diagram that I prefer is this one. That has the components of gravity. Yes, I do have frictional force, kinetic friction. I also have my normal force, which is perpendicular to the surface, and I also have the components of gravity. I will express the components of gravitational force in blue. So I have gravity parallel, FG parallel, as well as FG perpendicular. All right, together. I can either draw my free body diagram like this or like this, but I'll still get the same marks, né? But please, guys, do not leave your forces like this. Please write in full: normal force, kinetic friction, force of gravity parallel, force of gravity perpendicular, like that, né? A quick reminder: FG parallel is always given by mg sine theta, and then FG perpendicular is always given by mg cos theta. All together. So we can simply calculate FG parallel and FG perpendicular over here. Simply say the mass is 2, right? 2 multiplied by 9.8 multiplied by sine of 7 degrees, and then 2 multiplied by 9.8 multiplied by the cos of 7 degrees. 2 times 9.8 multiplied by sine of 7 degrees. The gravity parallel is simply equals to 2.39 newtons. And then now let's check the gravity perpendicular. That's 19.45. 19.45 newtons. Okay, let's work now, guys. I calculated those two forces because we will need them, no? First question, they want us to calculate the magnitude of a frictional force acting on the object while it is sliding down the incline. Remember that, guys, a frictional force is given by mu k. What do they want? The magnitude of a frictional force, right? Do you have a kinetic friction? The coefficient? No, we don't have. Okay. To answer this question, we are simply going to say F net is equals to ma according to the to Newton's second law of motion, right? We only have two forces there, guys. There's FG parallel and kinetic friction. Please, guys, always choose the direction of motion as positive. So it simply means every movement down the incline or towards the left is positive. Are you together? So in this case, remember that F net is sum of all the forces in one dimension, right? So I'll simply say FG parallel plus a negative frictional force. This is equals to ma, right? FG parallel, we did calculate it to be equals to at the top. It's 2.9, right? Why? It's 2.39 newtons minus kinetic friction is equal to 2 multiplied by 0. Remember that, guys, the acceleration is 0, right? Because there's no change in velocity. So therefore the magnitude of the kinetic friction is just 2.39 newtons as well. So the magnitude of kinetic friction is just equals to 2.39 newtons. Okay, and then 2.3.2, they want us to calculate the coefficient of kinetic friction. The coefficient of kinetic friction. Remember that, guys, there's a formula there behind the question paper. It simply says Fk is equals to mu k multiplied by normal force. Therefore, you can conclude that the coefficient of friction is equals to frictional force divided by normal force. Now, in this case, guys, whenever you have an inclined surface and there are no forces that influence our object at a specific angle, so it simply means that FG perpendicular is equals to the normal force. Are you together? How do we find FG perpendicular? By saying mg cos theta, and we did calculate it. We got 19.45 newtons. So for us to find the value of kinetic friction, we need to take our frictional force, which is 2.39 newtons, divide by our normal force, which is equals to FG perpendicular, that's 19.45 newtons. So 2.39 divided by 19.45. You'll simply get a coefficient of friction of 0.123. 0.123, right? Okay, and then now they want us to calculate the distance the object travels on the horizontal surface before it comes to a stop. The distance the object travels before it comes to a stop. Okay, now we are focusing on path BC. We know that the velocity at point B, let me just erase these things over here. The velocity at point B, the velocity of the block here is just 1.5 meters per second, and then it will eventually come to a stop at point C. The velocity will be 0 meters per second. Are you together? So in the horizontal surface, guys, the free body diagram of the block, we do have the gravitational force and the normal force, and also have the frictional force, which opposes the motion. Are you together? So remember that, guys, the 2 kg block is not being propelled to move towards the left in the horizontal surface. So there's no force pushing it to the left, hence it comes to a stop because it's experiencing an opposite force. Are you together? So if you focus on the horizontal dimension, we only have one force rather, and that force is a frictional force. Are you together? But how do we calculate the frictional force? Remember that we were told that the coefficient of friction does not change for both the inclined surface and the horizontal surface, right? 1, 2, 3. We can simply calculate the frictional force in the horizontal surface first, and then go and find acceleration. After finding the acceleration, we can go and find the distance traveled by the 2 kg block. How can you find the frictional force? Frictional force is mu k multiplied by the normal force. In this case, since this 2 kg is in the horizontal surface, the normal force will be equal to the gravitational force. Are you together? So you can simply say 0.123 multiplied by gravitational force, which is equal to the normal force. That's 2 multiplied by 9.8. What do we get? 0.123 times 2 times 9.8. You'll simply get to 2.41 newtons. That's our frictional force, right? Remember that F net is equal to MA. The only force which is acting here is the frictional force, and frictional force is opposing the motion of the block. Hence, we have a negative sign over there. Negative Fk is equals to 2 multiplied by the acceleration that we don't know. That's negative 2.41 is equals to 2a. Then the value of a, 2.41 divided by 2, that's simply negative 1.205 meters per second squared. Are you together? So now I do have the acceleration of the objects whenever it moves through the horizontal surface. Are you together? I know the velocity initially, the velocity final, and I also know the acceleration. So if I can write down the data that I have, I know that the initial velocity at position B, that's 1.5 meters per second. Final velocity, the objects will eventually come to a stop. I don't know the distance it traveled. I know the acceleration is negative 1.205 meters per second. I don't know the time it will take for the object to come to a stop. So I can simply use my equations of motion. However, I should avoid using any equation that has change in time. Why? Because I do not know how long it will take the object to come to a stop. So I can simply say Vf squared is equal to Vi squared plus 2a delta x. I know the final velocity will be 0. Initial velocity is 1.5 squared plus 2 times a negative 1.205 multiplied by delta x. Okay, and then 2 multiplied by 1.205 will simply give me 2.4, né? Negative 2.4. When I take it to the other side, it will be positive. I'll have positive 2.41 multiplied by delta x is equal to 1.5 squared, which is just 2.25. So the distance traveled, just say 2.25 divided by 2.41. I'll simplify the distance of 0.93 meters. So the block has traveled from B to C for the distance of 0.93 meters before it came to a stop. That's how, guys, we're supposed to tackle this question. For grade 12s, if you want to, guys, you can use your work energy theorem if you're familiar with work energy and power, or you can also use the work done by non-conservative forces. You will still come to the same answer over here, which is 0.93 or something closer to it. But that's how, guys, you should have tackled this past question paper. Just stay tuned, guys, and wait for more videos. Please don't forget to subscribe. Thank you.